going to do is we're going to discuss a case study which involved a project for Eli Lilly in Belgium. And it was a project of taking a existing facility that didn't have any, had not used containment whatsoever, and so we needed to convert that into a facility that could achieve the containment level that was required. So what we did is in this presentation, we're taking one piece of our equipment, which is a filter dryer, which had a heel removal glove box on it, and how we did the operator exposure limit testing on that. And the testing was done in our facility, but the important thing about equipment testing is that you should have it tested, but it should be tested, monitored, and the data should be reviewed by the client or someone like SafeBridge or someone who is experienced in that. It shouldn't be done by the vendor or the person who's manufactured the equipment, because that is a conflict of interest. So everything that is done should be done third party by someone else to validate that it does work. So this filter dryer with the glove box on the discharge is an example of some of the parameters we used, which was SMEPAC, which is now the ISP good practice regulations. And then we also used some of the client's parameters established by Brian for kind of more of an engineering application towards the operator exposure limit and how we use those. And so he's going to go into detail of how he does that at the end. And then what I did was I just put at the end of that some of the other equipment that was utilized for this plant that we developed. So it isn't going to be sales presentation, I promise. So I will let Mr. Ward talk, Dr. Ward, I should say.
I had the luxury of working with a company that did radiation monitoring back in the 1980s. I was able to monitor every operator in petroleum refineries, hospitals, several dental clinics, and found out that the operator data was the most unreliable data you could ever imagine. Until about 4 weeks of monitoring, they were assisting you to create data. They were either leaning towards the source, they were sampling downwind or upwind of the sample point. They were doing weird things, and until they realized the data was really serious and it really could track what they were doing, they performed for us. Hence, I don't like relying on operator data to do anything. So for the past 17 years, we've been trying to come up with an engineering way of getting engineering performance data from equipment. And in fact, the very first time we did this was when we did the IOC Dover qualification, because we used a combination of pre-SMEPAC, but it really was SMEPAC monitoring, or ISP good practices now, around the area. Plus we did engineering monitoring around the hardware. And that's where the original IOC Dover data came from. So, what did we do? Well, we wanted to do 3 unit operation studies for our glove box that we were buying. It was actually a filter dryer with a glove box discharge through a split butterfly valve. First time we bought anything this complicated, it was for the aircraft hangar, where we were going to have to make a potent compound so we can justify keeping the place open. And we did. We sampled targeted locations inside the space for a total of 3 hours during the study and also during the clearance time afterwards. We also performed the operator sampling. We also performed statistically random sampling around the equipment, the skin of the equipment. Where do we get that from? When the Asbestos Hazard Emergency Response Act came into existence in 1983, the EPA had no scientific basis for sampling. So what did they do? They went to the world's experts. They went to the nuclear industry who had 50 years of data and modeling of statistical sampling and said, what do? We want some confidence level that when we've done an asbestos abatement, the area is no worse than it was when we started, when we cleaned up. And we're dealing with one fiber of asbestos, which it turns out, very strangely, is about 0.2 micrograms per cubic meter, which is where many of our potent compounds are. So it's not a bad place to start from. And they were looking for a confidence limit on the data, statistical confidence limit, which you will not get from the ISP good practices. Good place to start something, but we need to move on from there and get statistically robust data. I'm not going to go through the next 2 or 3 slides because they just describe the unit operation. What I'm going to do is describe the study, some of the mistakes that we made, and what we learned from it. Because these are fundamental issues that anybody who does the current practice sampling needs to understand, because it will distort your data. We had an enclosure around the filter dryer. We were working in an industrial building where a test had been carried out for a glove box for our Fagersign facility just the week before. They had lactose in the glove box, and then they had the windows off the glove box while they finished completing the project. We were working right next to it. So we built an aluminum frame, excuse me, in Europe, aluminum frame, brainwashing, and put a room around it to isolate ourselves from the environment. The room had no ventilation. So anything that came out of the equipment was going to stay in the room during the course of the study. You could say it was a confined space if you really wanted to, but it was rather big. And we'd done studies like this in a refrigerator that was not being used many years ago and got surprising data, because the stuff stays there and it stays airborne, and you can see the legacy for a while afterwards. We found it usually takes a couple of hours without ventilation for the dust to settle in a room. So you better continue to sample during that period of time, because that's the challenge that you see. So I've given you a stepwise process of how we did the study and so forth, but let's get to the setup. We set up a series of arrays around the equipment, numerically, and then we create a statistically random set of sampling locations to take our personal bias. And then we also go after where we see we might have fugitive release points of dust from the equipment, flanges, split butterfly valve, a window gasket perhaps, a HEPA filter. They are unique locations. What we're going to look for is homogeneity around the envelope of the equipment. If we have homogeneity, we probably don't have a fugitive release. If we don't have homogeneity, we've got to go back and fix the problem. Then we should be able to replicate that homogeneity with consecutive studies. And if we can do that, we can pool our data. With 5 samples, you get 80% confidence if you can pool the data. With 2 studies with 5 samples, you get up to about 92% confidence if you can pool the data. With 3 consecutive studies where an analysis of variance shows the data is the same profile, you'll have over a 95% confidence. Not too bad. Why don't you have more than 5 samples? Well, you don't want to vacuum the area around the glove box with your sampling system, because now you're not sampling the homogeneous environment anymore.